Good evening everyone. I am Sampath Abegunsekara, Department of Civil Engineering, University of Morato, postgraduate student. Today I am presenting here influences of environmental factors in CFRP-Steel bonding state of the art. Other authors are Dr. J.C.P.H. Gamage and Dr. S. Pausia. Content: Introduction, Background, Objectives, Effects of moisture level or relative humidity, effect of thermal energy, influences of ultraviolet radiation, combined effects of environmental factors on CFRP steel bond, correction factors for environmental effects, conclusions, future works, references. Introduction. Deterioration of steel structures is a critical issue in civil engineering applications. There is steel plate or profile connected to a damaged position using welding or steel plate connected through bolting or to fastening. However, conventional retrofitting techniques have reported many limitations and shortage. Such drawbacks lead to increase in dead weight of the structure and susceptibility to the corrosion. CFRP strengthening technique was considered and became rapidly popular as one of best retrofitting techniques in civil engineering applications. CFRP material display a high strength to weight ratio, a less negative effect due to corrosion, high stiffness, high tensile strength, low weight, high chemical resistance, high temperature tolerances and low thermal expansion. Background. Evaluation of overall CFRP bond performance and long-term durability under real environmental conditions is not reported in the literature. Similar investigations conducted by different authors have different conclusions. Still, CFRP bond performance is depending on the environmental parameters such as temperature, salt environment, humidity level and UV effect. Most of the laboratory tests are conducted under controlled conditions. Environmental factors are kept as a constant during the testing. The combination of two or multiple parameters is involved with the final outcomes, and real environmental conditions are beyond human control. Analysis of the effect of all parameters simultaneously is practically impossible. Prediction is more complicated and the results vary in the wide range. Objectives. To understand environmental factors that influence on steel CFRP bond performance, discuss most critical parameters such as humidity level, temperature variation and UV effects or combined effects of these factors, to highlight correction factors and design guidelines available in the literature regarding environmental effects. Summarizes parameters influences of CFRP steel bond performance. Basically, they have several parameters: properties of CFRP material, characteristic of epoxy, environmental conditions, sample type, loading pattern, load applying methods, sample shape, bonding characteristic, installation procedure, condition of structure, stress conditions, joint type, specimen preparation, etc. However, here only focus environmental condition. Example: temperature variation, salt environmental, humidity level, freeze-thaw condition, UV effects, etc. Effects of moisture level or relative humidity. Increase of moisture to CFRP steel bonding joint can be considered as a major problem regarding bond performance. Both epoxy adhesive and CFRP materials are allowed to penetrate water molecules into the bonded joint. The results of water absorption attraction between CFRP steel and epoxy steel bond become weaknesses. Moisture absorption of CFRP matrix causes change in the physical shape of CFRP material. Physical changes of epoxy material have a tendency to reduce the glass transition temperature. Effects of moisture level or relative humidity. CFRP materials have shown excellent resistance to corrosion and chemical attacks. However, salt water may affect the material because salt can easily penetrate the fiber matrix. Mechanical properties are slightly decreased due to results of moisture absorption. The rate of moisture absorption. The rate of moisture absorption is very fast at the beginning and after that it's reached a constant level. However, the ambient temperature control the quantity of water absorption by the CFRP material. Glass transition temperature Tg of the adhesive is reduced through plasticization. Due to the penetration of water through CFRP steel bond, it has become weak. Cohesive pores or hydrogen bond or other valence bond of adhesive molecules is weak due to polymer inflation, and the result is delamination failure. Effect of thermal energy. Thermal energy also critically influences the CFRP steel bond performance. It can be described as two-way as thermal cycles and freezing conditions. Generally, a vast number of studies have confirmed that high temperature is an unfavorably influences on CFRP steel bonds. Carbon fiber reinforced polymer material shows excellent resistivity against elevated temperature of the environment. Epoxy resins cannot tolerate temperature elevation, and adhesive layer between CFRP and steel is highly sensitive to temperature. According to the temperature sensitivity, strength and stiffness of carbon fiber reinforced polymer steel bonds rapidly decrease. Usually this happens when environmental temperature exceeds the glass transition temperature of epoxy material. The mechanical properties of CFRP steel bonds reduce with temperature. Viscosity of epoxy increases due to the effects of temperature. The ultimate result is the rapid reduction of the strength and stiffness of the bonds. Generally, the glass transition temperature range of epoxy adhesive varies from 40 to 70 degrees. However, that joint is starting to slip before the glass transition temperature of the adhesive. The overall result is the reduction of strength before the transition temperature. Furthermore, the authors reported that a joint slip starts at around 40 degrees centigrade and its peak at around Tg. Since ultimate load bearing capacity is reduced when the temperature reaches Tg. Influences of ultraviolet radiation. Ultraviolet radiation is a part of sunlight of it causes to split the bond of molecule of the polymers. Bond dissociation is initiated due to absorption of the ultraviolet radiation. Dissociation is continued as a subsequent reaction with oxygen in the atmosphere. However, the depth of degradation is only up to a few microns. The damage area can be identified as the location of the high stress concentration. Recent research studies proved that when the CFRP material is exposed to artificial sunlight, it causes to vary the tensile strength. Test results reported that tensile strength decreases range varies from 15 to 20%. Researchers strongly recommended that the composite material should be protected from UV radiation because UV radiation with carbon fiber reinforced polymer material is more vulnerable than any other environmental effects. However, UV radiation does not significantly affect the change in tensile strength and stiffness of carbon fiber reinforced polymer. Combined effects of environmental factors on carbon fiber reinforced polymer steel bond. In the real world application, most of the above parameters are jointly affected on bond performance. However, few investigations have been conducted regarding the effects of joint influences of environmental factors. Carbon fiber reinforced polymer steel bonds are available in the literature. The influences of combined environmental factors is more complicated in the process of analysis. Most of the existing literature is focused on investigation of moisture and temperature. It's called hydrothermal effects on carbon fiber reinforced polymer steel bond. Akoy reviewed that hydrothermal exposure significantly contributes to reduce of the glass transition temperature of epoxy material. Correction factors for environmental effects. Environmental reduction factors, Italian guidelines. Environmental related partial factors, CFRP guidelines. Recommended values for partial safety factors for adhesive joint, ICE guidelines. Here table 2 shown Italian guidelines with internal environmental, external environmental and aggressive condition. CFRP guidelines shown in the table 3. Partial factors, partial parameters, adhesive properties determined for the environmental condition in services. ICE guidelines shown in table 4, partial factor parameters and environmental conditions, the parameters value and partial factor values shown in the table. Conclusions. Bond performance, durability and failure mode are critically influenced on environmental factors. Humidity and extreme temperature are causes that reduce the durability of CFRP steel bond. Temperature is causes to change bond performance because it is effects on glass transition temperature of adhesive material. Combined effects of several factors on bond performance, durability and failure mode. Highest influencing factor is moisture level, and most critical combination is influences of hydrothermal temperature moisture combination. Glass fiber reinforced polymer material is reducing the moisture absorption of the bond and act as a protective layer to control corrosion of the metal. Future work. Future research work is needed to validate accelerated environmental tests so that the actual environmental conditions are simulated. The bond behavior of the strengthened members subjected to dynamic loading, fatigue and impact should be thoroughly investigated, especially under severe exposure conditions. Long-term behavior of the carbon fiber reinforced polymer steel bonded joint under deeper loading and the environmental conditions should be implemented. Further, the factors affecting the bond slip model should be studied in order to make the relationship more reliable and useful. Acknowledgement. The authors gratefully acknowledge the support of the staff in the computer laboratory, the Department of Civil Engineering at the University of Moratuwa for their valuable support. So, references and thanks.